Right, moving on to Venn diagrams. Now, Venn diagrams are basically just a way of sort of displaying our sets so that we can better sort of understand them. So I'll give you an example here. Venn diagrams, normally we're talking about circles, so we always have a universal set, and it might be that or the squiggly E, and that is represented by a rectangle. Then here I've got set A and set B. Set A is the numbers 7 and 8, set B is 8, 9, 10. So I draw a circle for each one, and they have an overlap in the middle there. And I just label that up A and B. So I've got my universal set is everything in the rectangle. A is going to be everything in this left circle, B everything in the right. So let's put 7 and 8 are in A, but 8 is also in B. So the one they've got in common that goes in the middle here is going to be 8. So this centre section has 8. It's called a vesica-piscis, apparently, for those of you who are interested in the language of it. So if A is 7 and 8, and 8 is already in the middle, we put the 7 here. For B, we've got 8 in the middle there, and we put 9 and 10 over here. And we haven't quite finished because 7, 8, 9, 10, there's an 11. And if it's not in A, not in B, we can put it anywhere on the outside. So I'll put it there. So it's a way of sort of displaying your data. Now, when we are using those, we have unions and intersections to help us better talk about the sets. So A intersection, this end, well, it's not really an end, it's a sort of dome shape. That is intersection. And that is basically things that are in A as well as B. So in our example at the top, the intersection was just this section here, and it was the number 8. So if we shade that in there, that area there is the intersection of A and B. It's in A as well as in B. It has to be both things. Then we come on to this union, and the union basically means it can be in either A or B. So either A or B. So you can include everything that's in A, and I can include everything that's in B, and that is the union. We kind of bring them together. Bring everything that's in A, bring everything that's in B. That is the union. We're uniting them. Okay? Then we come to this A with a sort of apostrophe or a dash above it. And this is the complement of A. And the complement basically means not A. Basically everything that isn't in A. So visually what that means is everything that is outside the A. So everything there is the complement of A. And it's useful to notice that if you have A united with not A, that is everything in the world, the universal set. Okay? You can't have anything that's not in A and not in not A. Let's have a look at a sort of tricky example then. So we're going to try and shade on this diagram, not A intersecting with B. So let's go back to the language there. Intersection means as well as. So it's got to be not in A as well as it is in B. So I'm going to shade two different colours here. So I'm going to shade not in A. We already did that one above. So there it is, everything outside the A. And then I'm going to shade everything that's in B. And we need the bit where these are together, where these are both true. So here's B. Okay, so where have I coloured both things in? Well, you can see this section here has been coloured in pink and it was coloured in green. So that is the intersection of not A and B. So if I clean up my think I'll just finish that off. So the intersection was just this part here. That is not in A, correct? It's in B, correct. So always read back the sentence in your head and check it makes sense. All right, here's a typical number problem where it can be very difficult to work out what the sort of intersection of A and B is if you're only given certain bits of information. So here we've got a survey of 15 people. So my universal set is 15 people. The number in the universal set is 15 people. 10 like curry, well, let's call this a C here for curry, but P here for pizza. 8 like pizza. And 2 like neither. Well, neither is outside, so that one I can just put number 2 straight in. How many like both? Well, here the most common mistake is to just go curry 10, pizza 8. Problem is, this already adds up to 20, and then we only surveyed 15 people, so that makes no sense whatsoever. Don't do that. What we need to do, what we're saying here actually is 10 like curry. That means that kind of this section and this section, this and this add up to 10. So this pink area has to add up to 10. We've got 2 values there. Let's call this one little a there, a little b here, a little c there. So I know that A and B adds up to 10. The total, some of these people who like curry also like pizza. I also know that B and C add up to 8. Now, kind of the most useful bit of information is that there's 15 people, 2 like neither. So that means that A and B and C, so all of this in the middle of my Venn diagram, all of that has to add up to 13. Because I know there's 15 in total, there's 2 outside, so that means there's 13 left. 15 minus 2 means A plus B plus C is 13. Now I can use some sort of simultaneous equations here, and I'll just sort of go through that. If I take this one and I add it to this one, I get A plus B plus B plus C equals 18. And if you look, if A plus B plus C is 13, well, A plus B plus C, take that away and take away the 13, I end up with B equals 5. So that's one way to get the 5 in the middle of this Venn diagram. That's the answer we're looking for. But I actually find that way a little bit cumbersome. So what I would rather do is do it visually. So I like to highlight, we've already highlighted in pink this area. I know that the pink area is 10, okay? I've said that the pink area is 10. If the pink area plus C has to add up to 13, and the pink area is 10, well, it makes sense that C is 3. And then I've already got one of the numbers in there, so I'll put 3 in there. And once I've got that, I also know that C, the total, everything in B and C is 8. Well, that means that the B must be 5, because that makes it add up to 8. And then lastly, I know that the whole pink area is 10, so if there's 5 in the middle, A must be 5. So there's different ways to do it. You pick the way that works for you. Let's just tidy this up and finish it off properly. So what I found out was that 5 went in the middle, 3 here and 5 here. And you can always just check your answer at the end, make sure it all adds up to 15. 2 plus 5 plus 5 plus 3, I believe that is indeed 15. Okay, that's a little bit, a very quick talk about Venn diagrams.